limits with absolute value. Let's start with the definition of the absolute value of x. Absolute value of x is defined as follows. If quantity inside the x it's positive or 0, then we can ignore the absolute value. We can just say this is x. For example, absolute value of the positive 5 is just 5. 5 units away from 0. Absolute value of 7 is just 7. However, if the quantity inside is negative, less than 0 means negative, okay, then I can't just ignore the absolute value. Okay, let's see what we will have. Absolute value of negative 5, okay, we know that it's 5, because negative 5 is also away 5 units from 0. That means absolute value of negative 5, it's not negative 5. We know that it's positive 5. That means what we will do, we will copy this number, okay, but I will put extra negative to make the entire quantity positive. So let's come back. I did copy my x, but I know that this x is negative. I am making positive. Okay. That means this is the definition, and that's the way to rewrite the expression with absolute value without the absolute value. The quantity must be checked if it's positive and negative, and then respectively, that's the way to rewrite. Okay, let's solve a few limits. Limit number 1. Limit as x goes to 4 from the right-hand side, and the ratio of absolute value 4 minus x over 12 minus 3x. Okay, when we do the direct substitution, if I substitute 4 minus 4, of course, this is 0. Absolute value of 0 is 0. And 12 minus 3 times 4 is 12. It's also 0. Okay, that means first of all, we know that this is, at the moment, undefined term. The good news is we have 0 over 0. This is telling me that I do have a common factor between the function from the top and function from the bottom of the fraction. Okay. I have to figure out, I have to rewrite this expression, find possibly the common 0, cancel out, and then use the direct substitution theorem. That means this answer is not telling me much. Yeah? It's most likely not 0 because we can't divide by 0. Okay, let's see what we will do. We will rewrite without the absolute value. Limit as x goes to 4 from the right-hand side. First of all, I nicely see that I can factor out 3. 4 minus x. Excellent. And then I do have 4 minus x, absolute value, but I would like to rewrite without the absolute value. And also, it's a good thing, I will come back to my absolute value, that I have a line, constant and x. That's also helpful for my algebra simplification. Okay, I am looking at this quantity, because if this quantity is positive, then I can ignore the absolute value. I can just keep my fraction like it is. But if this quantity is negative, okay, then I have to put extra negative in front to make it positive. We remember from the definition. Let me let's check. X, it's not really 4. It's 4 from the right-hand side. 4 from the right-hand side, it's like 4.1, let's say. It means x is 4.1, 4 minus 4.1, okay? It will actually give me tiny number, but negative. And even if I will take a number closer, 4.01, I still have a negative number. That means the entire quantity, this one, I can say the blue one, it's negative. It's negative quantity. Then I will put extra negative. Okay, I have nice rational function, ratio of two polynomials. We can beautifully see the common factor. The common factor is cancel out. Okay, and then what's left? -1 on the top, 3 in the denominator. That's the final answer. negative 1/3. Limit number 2. Similar situation. X goes to negative 5 from the right-hand side, and the function is absolute value of x plus 5 over 4x plus 20. If we substitute negative 5, okay, negative 5 plus 5, negative 20 plus 20. Of course, 0 over 0. Yeah? Typical concept of calculus, we know that. Okay, now our job is to find a common factor, cancel out, and hopefully use the direct substitution here. X goes to negative 5 from the right-hand side. I will start with factoring out 4, and I see nicely x plus 5, which that's the factor that we're looking for. And on the top, I also have x, which is good, they align, and then plus 5. But the problem is, I have to check, shall I put the negative or shall I keep the positive? Okay, we have to figure out if this quantity, I can use my blue color, if the quantity in the parentheses is positive or negative. Let's check. X plus 5. X is actually 5, oh, I'm making some. X is actually 5, negative 5 from the right-hand side. Okay. This is negative 5, and the right-hand side is on this side, but since this is negative number, the number will be like negative 4.9. And we do have negative 4.9 plus 5, okay? And I see actually that this quantity is positive. I mean, I can just leave it, I can leave it like that. And I will cancel out. Okay. And I have positive 1 on the top and 4. Of course, I can remove the positive. 1/4 is the final answer. Limit number 3. 2x minus 14 over absolute value of 7 minus x, and x is approaching 7 from the left-hand side. Okay, that's what I see. Let's check if we do have a case 0 over 0. 2 times 7 is 14 minus 14. 7 minus 7, absolute value, of course, is 0 over 0. Yeah, it's undefined. That means, yes, this is the case. Let's rewrite. Limit x goes to 7 from the left-hand side. Okay, first of all, I can factor out 2. From the top, I don't have absolute value. I can just do my algebra. Okay. And then I have 7 minus x. That's my absolute value quantity. And I have to investigate if this quantity is positive or negative. Okay, let's do the same. 7 minus x. X goes to 7 from the left-hand side. 7 on the left-hand side is like 6.9. 6.9. 7 minus 6.9 is actually positive number. Okay, that means I can leave it this like it is, positive. Well, let me keep switching. The one thing that we have to take care now, after we took care of the absolute value, you may notice that our numbers are not aligned. Constant, constant, XX is not aligned. I will switch the order. Switching the order, we will need some extra negative, but that's different. This is just algebra. We took care of the absolute value. I mean, I can possibly keep my 7 minus x on the bottom, and if when I factor out negative from the top, 7 will become positive and x will become negative, right? Because negative 7, negative times negative, positive x, and that means I'm just switching. I'm switching the order 7 and x, but I have extra negative in front. Okay, now I can nicely see the common factor, the common 0, 7 minus x. And the final answer is -2 and 1 in the denominator, -2. Limit number 4. Okay, when we put 6, limit as x goes to 6 from the left-hand side. 6 minus 6, 0. 6 minus 6, 0. 6 minus 6, 0. Of course, it's 0 over 0. Okay. Let's see, because we do have absolute value and we have to rewrite without the absolute value. Limit as x goes to 6 from the left. X minus 6, that's without the absolute value. X minus 6, this is without the absolute value. But then we do have quantity x minus 6, and I can use my blue color. That's my absolute value quantity. I have to figure out if I have to add extra negative or not. Let's check. X minus 6, the quantity that I am testing, this one. X is approaching 6 from the left-hand side. What is the number? 6 from the left-hand side is 5.9. Okay, 5.9 minus 6, it's actually a negative number. Okay, that means I do have to add extra negative. Have to be really careful because we have lots of negative numbers. Limit as x goes to 6. Okay, x minus 6, x minus 6. And now this negative and my negative actually becomes positive. Okay, because we can see that negative and that negative, this is the negative from the definition of absolute value. We can probably see the answer now, but let's make a nice simplification. X minus 6, x plus x is 2x, negative 6 and negative 6 is negative 12. Okay, and then limit as x goes to 6 from the left. 6. We do have x minus 6, and in the denominator I can factor out 2x minus 6. And that's my common 0. 1 left on the top, 2 left in the denominator. Okay, and the last one, x goes to 1 from the left, 2x times 1 minus x over x minus 1, absolute value. If we substitute 1, we can definitely see it's the case 0 over 0. Let's take care. Limit as x goes to 1 from the left, 2x times 1 minus x. And then I have x minus 1, that's my quantity from the denominator. I mean from the absolute value, that's the most important. And I will investigate if this quantity is negative or if it's positive. X is 1 from the left. What is the number on the number line? 1 from the left. From the left-hand side, we do have 0.9. 0.9 minus 1, it's actually a negative number. Then I will put extra negative. You may realize we can't simplify because they are not aligned. We're supposed to have x underneath x and the constant. And luckily the constant is the same. That means let's figure out. I will rewrite my limit. 2x. I can keep this one for now, but I will change this order. Instead of 1 minus x, I will put x minus 1, but we know that this results in extra negative. Okay, now we can beautifully see the common factor, x minus 1, and actually negative and negative is positive. But I can write it down, the quantity, and what stays, and since we have x, we still have to keep a limit. Okay, we do have negative negative 2x, negative 1. But as I said, this will become positive. X is 1. I can do my direct substitution. 2 times 1 over 1, of course, is 2. Thank you.